Hello, students. I got a couple more questions that came up about the homework, so I'm going to go ahead and post those here. Let's see what we ended up with. So it was 11.1 and so thank you for reaching out. I do appreciate it. Number 15 and number 16. Okay, and number 1 on the MC. Okay, let's take a look at that. So, oh, oops. Oh, now my computer was frozen. Okay, we're back. Okay. 15 and 16. So let's take a look. 15 and 16. So here we go. Consider a correctly functioning clock that starts ticking at noon and find the time between noon and 1 p.m. when the angle measure is exactly 180 degrees. Okay, got it. So interactive clock. So again, so this one is this is from noon to 1 p.m. So I just Googled interactive clock. So it says toytheater.com, whatever. Okay, so first off, I need to get it to noon. So let me go up here to noon. There we go. Okay, so here we go, noon. So I want you have to picture it first, right? That's the key. You have to be able to picture these. So there's noon. As the hand oops, I'm moving the wrong hand. It's going too quick. There we go. So as the time starts ticking, choo, 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 right? You can see eventually it forms a 90-degree angle, somewhere close to this. Probably not exactly that. That looks a tiny bit off. And it's not to the nearest fraction of a second anyway. And you would be asked to find it to the nearest fraction of a second. So it looks like, look at that. I mean, it looks pretty close. Doesn't it look pretty close to 180 degrees right there? So maybe at least in my mind, I can kind of see it's 12:30. So again, in my mind, as I look at this, I know it has to get at least halfway around to be 180 degrees, but it can't go too much further than that or it'd be past 180 degrees. So even without this clock, I can still get an idea of about where the hands would be. So it's got to be after 12:30 and before 12:40 because that would be just too big of a gap. So somewhere in there it happens. And let's see here. Let's jump in and get a little white space. Okay. So here we go. Okay, so once again, we have to look at the hands. So I'm going to kind of shade those in. So I've got our hand right here. Okay, now remember from my prior one, this thing moves 30 degrees in an hour, which is half of a degree per minute. And it did start at noon, so there is plus 0-degree head start. If it started at 1 o'clock, then it would have a 30-degree head start. If it started at 2 o'clock, it would have a 60-degree head start, and so on. Okay, so there we go. So now let's see here. What do I want to do? Oh, now I need the minute hand. So let me change colors. The minute hand right here, it started at noon and it moves 360 degrees in an hour, which is 6 degrees per minute. And so what I need though, you have to look at this. Which one's going to be ahead? So the blue one will pass all the way down to here. The red one will only make it to here. Okay. And let me get rid of these other angles on the outside so they don't distract you. Okay. So wherever that does actually meet, so if you think about it here, here's wherever, so this red angle started at noon and moved over. It's just a small angle, but the blue one's over here. And I want you to think in your mind, you need big minus small. The big angle in this case is blue and the small angle is red. And so then you can set those up and do blue. 6 degrees times minutes minus red. Red is half a degree per minute. And we want that to equal, I'll just keep this equals 180 degrees. So subtract, you get 5.5 m equals 180 degrees. Again, they're both degrees on both sides. So we're going to cancel that off when we divide. And we will divide by 5.5, divide by 5.5 degrees. And the degree symbols go away, and it leaves you with a really nice little m equals 180 over 5.5. We could make that 1800 over 55. This is the FLOF, right? Fundamental law of fractions. So scale up, multiply everything by 10. Let's see here. Maybe we could divide everything by 5 next. That'll probably make it nice. We can simplify this. And let's see here. 1800 divided by 5 is 360. Okay, so I get this equals 360, and 55 divided by 5 is 11. So my answer is 360 divided by 11. So 360 divided by 11 is 32 minutes and then 0.72, right? I mean, I could rewrite that as a fraction. Maybe that's easier. Maybe the repeating decimal is fine, but that's how many minutes. If I want to the nearest second, then take that fraction of a minute, 0.727272. Make sure it's still in your calculator, 0.727272, and multiply that by 60. And so you get 32 minutes and then 43.63 repeating seconds. And if you want, you can keep it that way. If you don't, I mean, you could multiply that, the remainder part by 11, and you could also get this as 32 minutes, 43 and 7/11 seconds. So either one of these down here would be just fine. So how long has passed? 32 minutes, 43 and 7/11 seconds. All right, so let's come over here and kind of say, well, what are you going to do, Scott? Are you going to put one of these on the test? I mean, if you can't see that right now, yes, I'm going to put one of these on the test. It ties in too many concepts to just leave it off. So let's talk then briefly. What would you do if this was a different time? So I'm gonna bring this hand back up to the top, and let's just say this is all you know is where noon is. Let's say that we're going at 4 o'clock, maybe. Why is this? Okay. No. Okay, there we go. I don't know what happened there. I clicked the wrong button. I must have clicked one of these icons. Okay. Okay, so here we go. So there's my tool. So now watch this. What if, let me clear everything. What if it was, I don't know, 5 o'clock? Okay, 5 o'clock. And I want to find when do I get to a 90-degree angle? And it's 5 o'clock. Okay, so I'll come over here to the side and I'll sketch it out for myself, kind of say, what does the 5 o'clock one look like? Well, around 5 o'clock, the hour hand's going to be somewhere down in here, right? Because it's after 5 o'clock. That's the hour hand. The minute hand has to be somewhere over here for it to be a 90-degree angle. Okay. Now, if you take a look, the blue one has only gone this far. The red one actually has gone all the way down here. So the big angle this time is the red. And the red would be half a degree per minute plus, and then count all the head start because it got down here to the 5. So that's 30, 60, 90, 120, 150 plus 150. Okay. So there it is. 0.5 M plus 50 minus the other hand, minus 6 degrees per minute is equal to 90 degrees. Okay. Let's see here. So this becomes a negative 5.5 degrees M because 0.5 minus 6. And then let's take the 150 and kind of bring it off the other side to minus 150. So the answer over here is negative 60 degrees. And then I'll just divide by negative 5.5. And so M turns out to be, let's see here. I could call this 600 over 55. Again, just simplifying a little bit. The degrees go away, the minuses go away because negative divided by negative is positive. And this becomes 120 divided by 11. So 120 divided by 11, and I get 10 point something. So that's 10 minutes. Take away the 10, leaves me with the decimal, multiply by 60 to get seconds, 54. Take away the 54, multiply by 11, which was our denominator, and I get 6. So There it is. So when would it happen? It happens at 5, 10, and 54 and 6/11 seconds. That's the time. Okay. Now, if you look at my drawing's pretty close. Again, I'm just ballparking it, but it looks like I got right around 5:11-ish. So that's pretty close. Okay. But just think what happens now. What if time just kept on ticking? Tick, 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 tick. Eventually, this hand is going to keep going past, right? And it's going to end up somewhere over here, while the red hand, which will now be purple, keeps on ticking itself. So it gets somewhere down in here. It is possible that we get another 90-degree angle. But that 90-degree angle would not be red minus blue. It would be blue minus red. So that would be a little bit different, right? So if you take a look, what's that one going to look like? It's going to be 6m minus the red one. And the red one is 0.5m plus 150 degrees equals, and I want that to equal 90. Okay, so once again, I get 5.5m, this time positive, but now I get a negative 150 when you distribute. So that's negative. So I'm going to add 150 to both sides to get rid of that because it would be negative. So I get 5.5m equals 240, and then just go ahead and divide by 5.5. And that's 240. And so I end up with m equals 240 over 5.5, which is 2400 over 55. And let's go to the calculator. 2400 divided by 55 gives me 43 minutes. Minus the 43 on my calculator, multiplied by 60 at 38 seconds, minus the 38, multiplied by 11, because that's my denominator, and I get a 2 and 2/11 seconds. So what this says is there are 2 times between 5 o'clock p.m. and 6 o'clock p.m. There are 2 times when the clock has a 90-degree angle showing. One of them is at 5:10 with 54 and 6/11 seconds, and the other is at 5:43 and 38 at 2/11 seconds. Those are your 2 times. Could you do this for any time on the clock? And the answer is yes. Yes, you could. Again, just remember, if you sketch it out, you can kind of get a feel for where the hands are. Remember, if it's between 5 and 6 o'clock, the hour hand has to be located in here. And if you just kind of sketch it out, you can be like, okay, well, I know there has to be one over here and one over there. And that's all that I did. One to the left, one to the right. All right, let's take a look then. What's next? 15, 16. Okay. So these all look pretty similar. Okay, all algebraic in nature, question 16, but you just have to kind of set up the equations. And so that's the piece for you. Maybe that's the tough part for you, is kind of seeing what equations would I have, but that's where you want to use the picture. I will always give you information about what's going on. So it doesn't matter to me. Let's see here. So both A and C, if you notice how they form a straight line, that's a straight angle. So those add up to 180 degrees. In part B, it adds up to 90 degrees. We can see the right angle mark there, right there. So yeah, it doesn't really matter. It doesn't matter to me. Hopefully it doesn't matter to you because they're basically all the same, but let's see here. Okay, so I'll just do, it doesn't matter, right? They're basically the same. Why don't I do, everybody says I don't do the hardest one. So this one is part C. So maybe part C is the hardest one. I don't know, but let's see here. X plus Y has to equal 180 degrees. That's what I know because they tell me X is here and Y is there. and they have to add up to 180. Okay. Next up, the measure of angle AOB. So find that angle AOB. Okay, that's X minus the measure BOC. BOC, that's Y, has to equal 50 degrees. Okay, so X minus Y has to equal 50 degrees. And now you use the techniques from chapter 8. That's why we covered that before we got here. And if you add these together, off you go, right? So two X's, the Y values go away, and that equals 230. So X, now we just need to get X by itself. So we'll divide by 2, and it looks like I get 115 degrees. Okay. So if X is 115 degrees, you can take it and plug it into either one of the top two, doesn't matter, because 115 plus something has to equal 180. So I could just do 180 minus that 115, and that will get it to me. Again, what's great is that really the basis here of doing that algebraic component, like getting this value, it all hinges on you doing the 4-fact families from Math 105. So when you saw that 3 plus 2 equals 5, you also knew that 2 plus 3 is equal to 5. You also knew that 5 minus 3 equals 2, and you also knew that 5 minus 2 equals 3. Okay, why is that so important? Well, over here, what did we have? We had X plus Y equals 180, right? Well, if I know my 4-fact families, I could just say it's addition, which means Y, right, is equal to 180 degrees minus X. Done. Right? And I know what X is, so I can just plug it right in. So I don't need to go back through tons and tons and tons of additional work. At least in my mind, I don't believe you do. And I think that's great. Or you could use it here. You could use it on this one. So if I knew that 115 degrees minus Y equals 50 degrees, I could use this 4-fact family and say, oh, well, that's the same as 115 minus 50 has to equal Y. And I don't even need to think about the algebra, right? You're building the foundation for the algebra, but really, in a sense, you don't even need to think about the algebra. It might be quicker for you if you didn't think about the algebra. So you could get the 65 degrees, and then you can check, yes, they add up to 180, and when I subtract, I get a difference of 65. So again, use those skills. That's why we're building those skills to go about it. And yeah, if you were doing A, so someone's like, oh, well, A is harder. I don't know. You have X plus Y plus 120 equals 180. Well, get rid of 120 off of each using the balance scales. And now you have X plus Y equals 60. Okay, so the numbers are already smaller. So all up to you. All right, let me double check and make sure that that is it for the questions. Oh, question 1 on the MC. All right, let's take a look. Question 1 on the MC. In the drawing below, we see there are 2 distinct rays drawn with the same endpoint, and there's 1 angle determined. With 3 distinct, wait a minute, that drawing right there, see the little hole? Ha! That's not a ray, it's a half line, because these authors are trying to be all fancy, but I caught them. Nice try. Okay, so then if I add, if I had 1 more ray in the middle, okay, with 3 distinct rays, then I would have 3 angles. And this is where, I mean, you have to be a little cautious here. This is actually obviously I signed it for a reason, but this one's like, okay, I see the red angle, which is the small one. You may need to color code them. The way they do it is with these pink ray or these pink little arcs, and it can be hard to see the difference between them. And so really, this is what they're referring to. Big one, green, smaller one, blue, smaller one, red. That's what they're talking about. Okay, so they're saying continue this pattern. And really the pattern is they don't tell you the pattern. You have to go figure it out. And so when you do this, I expect at this point that you say, okay, I can do this. All I have to do is start drawing and counting as I go, but make it so that it's easier for you to see, if that makes sense. Okay. What am I referring to? Well, if I was doing something like this and I had my 2 rays, there's my 2 rays. There's definitely 1 angle, that's fine. If I built 1 more ray in the middle, Okay, and I wanted to count these. My approach would be to start with like the top ray and work my way down until I've used every angle that could be created with that top ray. So it's kind of working through the process, but not just randomly. So I would form down every small angle. There's one. Then I would form the next angle down, which goes to here. That's two. And that's it. That's all that I can form with those. Then I switch it up and I go from the middle one and I continue the process down. What you can see here is there's one brown and two greens. And again, I know I've said this before, but it's so tempting to think of just putting everything together and saying there's three, when really what I hope you can see is that it's actually one plus two. So yes, the answer is three, but it comes from somewhere, right? Okay, so let's go back and try that again. Let's try it with one more, and then I'm going to leave it to you, okay? Because this is part of the MCs, is that you are going to be a teacher and you want to, sometimes you will struggle as a teacher. I'm not going to lie. You may not know the answer right away, but I want you to have that idea that I have enough thinking skill that I can get there. So I'm going to draw one ray, and then I'm going to draw one other ray, okay? So now how many do I have? Again, make a pattern. Look for patterns. Start at the top, work your way down. One, two, right? Three. So there's three going from the top ray. Next up, I'll go to the middle ray. One to here, one to here, right? Measuring the angles. And finally, one to there. That almost looks like the same. Let me change that one just so it brightens up our life just a little bit more. Okay, let's try this. Is that good enough? That's yellow. That didn't do very good. Who's choosing these colors? Who's in charge of this ship? There we go. Orange looks a little bit better. Okay, so I have one orange, right? I have two browns, and then I have three black, which again does give me six. But there's a lot of different ways to get to six. Maybe if I was drawing it differently, I wouldn't see a 1 plus 2 plus 3. Maybe I would in a different shape or a different thing. I might get something like a 4 plus 2. That is different than a 1 plus 2 plus 3, right? So maybe in this one, maybe in a completely different picture, not this picture, my next one was a 5 plus 3 because I see a pattern coming, okay? That is very different than the next one up top, which might be 1 plus 2 plus 3 plus 4, but you have to make a conjecture. You have to discover a pattern and see what it is. And again, it says no reflex angles, so it's not referring to reflex angles. And remember, if you're like, what the heck is reflex angle? Reflex angle would be this one going around here. Okay, so we're not talking about that. All right, that's it for now. Hope that helps, and off you go.